Hello, good morning, good afternoon. Welcome back to our session. This is 1 Million STEM Teachers Program implemented by Afribot Robotics. My name is Willie Jassing and I work with Afribot Robotics. In our last session, we discussed, we had an introduction to programming with Robosim. Before that, we managed to build our robots, we managed to assemble robots based on the manuals, the curriculum that comes with the Robosim platform. Today, I'd like us to dive a little bit deeper into teaching and training. Before that, I want to just give you a tour of some of the resources you have when it comes to teaching and training. There are around 8 maps that have been built for you from introduction all the way to advanced levels that you could explore as an educator. So I'll start with this, the STAR quiz. So this is about, it's more on deep space exploration. So I'll just open the map straight away to save on time and play it. It's already programmed for you. The first example, and then the second one now you get to program and debug your own robot. Actually, you get to build fast. So you can see this robot is navigating the white path. It's heading to do its first task. Very good, it has picked it. Heading straight to throw it. Very nice, fully placed. The beacon zone. Heading towards the end zone, as you can see. Very good. And you can see the scores are also in real time. So once a robot passes the flag, the score assigned to that flag, you'll see it reflected. All right. Great. Interesting. Very nice. Now, I want you to take note of when this robot is moving. Of course, it's using 7-channel infrared tracker. Okay, I'll show you in the next clip. But I wanted us to discuss something on the data panel. How you can get to monitor the state of your robot using the data panel section. So I'll head back. I won't be able to show you all of them, but I'll select 2 more. I'll head to Smart Factory, and then I come and finish with the intelligent logistics. Let's see what's here. So Smart Factory refers to the active development of emerging strategic industries such as new energy, new materials, advanced manufacturing, and electronic information, while also fostering future-oriented industries to accelerate the formation of new productive forces and enhance new drivers of growth. So I'll open the first map, the training platform that has already been programmed for you to learn, to use for learning. Yeah? So I'll quickly check on the robot build. I want to comment something on the robot build. So again, you can get to modify this design if you want to. You can import your own design if you prefer importing yours. And just to highlight a few things that I can see here, there's an RFID module here. I can see there's a mini motor. There's also now on the drivetrain. On the drivetrain, I can see there are 2 competition motors here attached to the wheels, and then there's a caster wheel here. There's a caster wheel called it universal wheel. It's around 24.5 mm. There are 2. There's another component, I can't see it clearly. Okay, oh yes, there's another motor here for actuation. Of course, I mentioned it. Then we have the E6 ECU or E6 controller. So I'll head straight into the simulation. So on the simulation, I'll click on the play button, and you see the robot is moving. Okay, so active computing activated there. Interesting, very nice. Let me zoom that. Let me have this camera to follow the perspective. Okay, interesting, very nice. You can see the robot is faster, it's moving very, very fast. Industry safety connectivity, very good. Which station is this? That is deploying network nodes, success, very nice. All the way back to the starting zone. And you can get to see the data, the task data, smooth launch 40/40, return to base 40/40, activating computing core 60/60, running energy vehicle 60/60, deploying network node 60/60, industry safety connectivity 60/60. So in total, we have around 320 points. And you can also get to see the duration, because time matters a lot when it comes to robotics. If you have a robust robot, properly designed, then all you need is a very, very good algorithm for you to save on time, be able to complete of the task in the shortest time possible. So this simulation, we were able to complete it in 44.76 seconds. Okay, so this is great. Now imagine if this was a competition. 44.76, you're done. Okay, this is super. I like it. Okay, now let's proceed. Let's check on the last one. Before we begin our session. Let's check on the last one. So I'll check on the intelligent logistics. Let's see. We're just admiring the programming behind these pre-built tutorials or examples. Again, this is already built. You can just check the robot. If you go to the build section, this is not using a 7-channel infrared tracking module. This is using an array of photoelectric sensors. So there are 1, 2, 3, 4, 5. There are 5. 3 in at the center used to track the line, and the ones at the end are used to check the turns. So again, on the drivetrain, we have the competition motors. We have 2 of them attached to attached to the wheels. There is an LED here. This is this is more just to give you some signals for you to be able to know if your robot is on the right track. Colorful lights. Then there is a camera here. This is an AI vision module. There are plenty of libraries for programming this. There is a competition motor again here for what exactly? This must be for actuation, but is it connected? Let me see. Okay, this is not connected at this time, but I guess kuna kazi yake, so we'll get to see. There is another motor. There's a servo motor, very small. There's an RFID here, and of course there is an E6 controller. So I'll head straight onto the map. I'll zoom it. I'll click on play, and then I'll give you that view, because I want this camera to follow the robot. Okay, let's watch. Look at the performance of this robot. System activation, success. Interesting. Wonderful. You can see the LED. Receiver information success, and it scored some points there. Interesting. So let's see what's happening here. You can see the LED again. Door-to-door collection. Interesting. Again, there is now, before programming for anything, there is sorry. there's a PDF that you can get to download. Then once you download that PDF, you'll be able to see the rules and themes of that particular game. Okay, you'll be able to see the rules and theme of that particular game. Customer service. Interesting. Okay. Interesting. That was weighing the goods, around 30 points. And returning home. Done. So managed to do all this in 96.16 seconds. And you can see the task score is 640. Okay. So this is really great, and you can get to see where you got the marks, where you lost the marks, and debug appropriately in case you didn't get it right. So I'll go back to today's session because we need to begin. I'll go back. I'll click on teaching and training, and I'll start with a blank space. Okay, I'll start with a blank space. Now, the reason I'm starting the blank space is I want us to learn forwarding and turning, okay? Because forwarding and turning are more the primary, the basics for performance in robotics, mobile robots. So before we get deeper, it's important for us to know the different turning techniques, okay? And how to check if my robot is working properly or not, okay? So I'll import just a simple robot here on the platform, and I'm interested to know where is this robot facing. So to know that quickly, I can just do a simple code. I can do a simple code for motor 1, motor 2, and then this is just to command the robot to go forward. So if I come here, I expect to know this is now the true forward of this robot upper. I don't need to modify the motor. I don't need to, if you wanted this side to be forward, then I'll just come here. I'll just come to the motors. I'll click on the motor, and then I do reverse motor. And then I come to this other side and I do reverse motor. So we are done up to that point, okay? So I'll come back now to explain deeper on the Robosim programming platform. So on the top right corner, we have the blocks, okay? So here you can get to switch which language, which platform you are comfortable with. If you are comfortable with the blocks like the Scratch, you can get to click that. If you're comfortable with Python, you can just click on Python, and then from here you can type anything. You can call your robot directly. You can also program this robot in C, okay? In C, and already you'll have your IDA files and everything. It has autocomplete, so once you start typing, of course, it will give you suggestions, and just continue. If you want to go more custom, you can connect this to your Visual Studio and program it directly. Also, for those who are transitioning from block to other languages like Python, you can always view your code on the bottom right corner. There is view code section. There is course, okay, course. If you are stuck maybe somewhere and you want to learn how to go about line patrol, okay, so you can see this is line patrol. Like there is a function inside a function inside a function inside a function. Okay, it's interesting, but for us, we want to start with the basics first. So we said basics first because we want to understand what we are doing. Okay, so I'll click on the course. I'll minimize that, and then I come back. Okay, I'll come back. I'll come back here to the robot. Then I click on the programming section, and I click on now back because it's time to do the programming. Okay, so let me just minimize this. Just a second. So in case you're having a challenge with that, you can just delete your robot and then you can, yeah, so we don't have a robot to program here. Just a second, I'm troubleshooting something. Okay. So I have my robot back. And then so if you want to view the code in Python, you can always check how this looks like. Okay, so this again, just a combination of functions. There is no code that can run here. So these are more comments until you call them. Okay, until you call them to your code. This is just to help you understand. Okay, to help you understand programming. As you can see, I clicked on course. So if I could have not clicked on course here, aingekuja. So you can also check for visual line control, how it looks like. If you want to do visual line control, this is how to go about it. Okay. So everything in detail you can always follow. If so, I'll click back. I'll click back. I'll click back. I'll click back. Okay. So we are back. Now that we are back, I'll start by explaining now. This is the side. So if you want to save your program to a local file, you click on this icon. If you want to load the local program file, you click here. If you want to simulate, you click this icon. So in simulation, there is debugging mode and the full simulation. So with debugging, you can click your robot, you can drag your robot where you want it to start. If you want it to start here, and then you click on that debug. Okay. For this, once you click, it will just go to the home position. We'll get to see that once we start debugging or programming. This icon is for simulation. This is for programming. As you can see, we have more of a scratch interface because this is what most beginners are comfortable with. And then we have the building. Okay, we've been interacting with building for the longest time. We've designed our robots. We've tried to program them on our own, and I believe we should not be spending a lot of time there at the moment. Now, if you go to the RCU, we have up to 8 tasks. Okay, so task 1, task 2. So when this robot starts, what is that one thing that you want it to run? Okay, so you can have as many. This is more like a header. You can have as many instructions as possible, but this has to come first. Okay, when you start, then do this. Okay, so you can have go to the show, go to the market, but then when you start, okay, then now it will be executed in that order. Under motor, we have set motor, we have set servo, we have these are. I think it will be more interesting if I use an example. If I use an example to teach that, okay. If I use an example to teach that, okay. So I'll use this robot, the one we already have here, okay. So if I say when this robot starts, set motor 1 to speed 50. If I run this file, if I run this code, you can see my robot is going in circles. Okay, my robot is going in circles because motor 1 is running and the other motor is not running. Okay, what if I say that set motor 1 and motor 2, I change this to motor 2 to 50, what will happen? So you can see I'm having a smooth motion, and if you look at the data panel, I have 50 and I also have another 50. Okay, on the data panel section. So I have 50 and 50. So I wanted you to see this. So I will need to minimize my recording screen so that you can see everything I am doing. Okay, most of the data panel, I feel it's very, very, very important. This is second. Okay, very good. Very good, very good. Okay, so I'll stop. I'll go back, and then we have okay. This is motor 1 to speed. If you look at this robot, it's still moving. Okay, if once it gets here, there is no instruction that is stopping it from moving. Look at the robot. See, the motors are still on. The motors are still on. The robot is still moving, and the timer here is still counting. Okay, until I click this button, the robot will stop now. If I say move, okay, there's a difference between this block. Let me delete this block and this block. Okay, if I say set motor 1 to speed of 50, okay, and then I simulate this, you can see it's going in circles and it's not stopping. But if I say set motor 1 speed of 50 at an angle of 90, did you see? Motor 1 speed of 50 at an angle of 90. So motor 1 is moving, but then it's maintaining angle of 90. So once it takes that rotation until angle 90, it will stop there. Okay, so from now it continues to compare the encoder value. So from where it starts to where it stopped, the angle in between is 90. Okay, you can see it just stopped immediately. So this is always good for when you want to move precise distance, or you want to do like a very, very sharp turn, like an angle turn, or when you're working with servo motors, that is when you are actuating things, or you follow the line, for example, or you've been moving around that map, and now you are somewhere, now you want to lift some load, then it's important now to use these angles. Okay, so again, motor 1, motor 2, motor 1, motor 2, until the coding value is 1000. So let's see again. I'm instructing the two motors again to move, but then this time round until I get to 1000. So this is 1000. The coding value is 1000 here. Okay. So again, this again, if you want it to be half of that, then you'd say coding value to be 500. Okay. So 500. So if I say 500, you can see half of that. If I say 50, okay. If I say 50, okay, very small. Now that we're there, now that you've learned the difference between set motor to speed, set motor to speed at an angle, and set motor to speed at a coding value. Okay. Allow me to proceed now to okay. Now this is now for small motor. There are small motors that are connected directly to ports, and for this controller, it supports P4, P5, and P6. Kindly take note. Our robot, this robot has around uh, 12, 12 input output ports. If you count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, out of the 12, we have 4 dedicated motor ports. Now, 4 dedicated motor ports. If you check, okay, they're not labeled here, but if you check, you'll realize that we have 2 and 2, 4 dedicated motor ports, and then 8 input-output ports. Now, the input-output ports are ports that you can connect any sensor, okay? They are ports for sensors only, okay? But there is an exception for small motors. Now, steering gear, small steering gear. Now, it's not all the ports. You know, we have P1, P2, P3, P4, P5. If you look at, for example, for the sensors, we have P1, P2, P3, P4, P5, P6, P7, okay, P8, okay, P7, P8, okay. But, kindly take note, oh, okay, I think you're not seeing my screen full. I need to adjust it again. Okay, I need to just have it visible. Okay, sorry, I was fixing something there. I'm done now. Sorry for that. Okay, I realized that you are not seeing some part of my screen because I'm using a white screen. So I wanted to adjust it. Okay, sorry. Now, if you look at the sensor ports, they are P1 all the way to P8. But then we have an exception when we are connecting small motors. We can only connect them to 3 ports. That is P4, P5, P6. Okay, and yeah, and also for the camera. For the camera, we have a special port around P5. So for your small motors, you can also connect. Besides the M ports, you can also connect them here. Okay, that is done. Then we have small steering gear before angle land. So when you see angle and encoder value, so this is more like a distance. Okay, so rotating at angle 90 at this speed, Then besides that, oh, okay. Setting the servo. We have also setting the servo directly to an angle. So if you have a motor that you've connected that like an actuator, you can command it to go to a specific angle at any given time. So that said, allow me to get to the sensors. We do have touch sensors. We have color sensors. We have ultrasonic sensor. We have light sensor. We have color lamp. We have multiple sensors. Now today I'd like us to just discuss 2 of these sensors. I'd like us to discuss light sensor. Okay, I'd like us to discuss light sensor. So light sensor, it emits light and then reads the reflection, the reflected light, the value of the reflected light. So when light is, for example, if you shine light on a dull surface, it will tend to absorb more. If you shine it on a bright surface, it will tend to reflect more. So now using that principle, you can either get Boolean values, that is 0 and 1, or you can get an analog value array, a wide range that you can use to determine if more light has been absorbed or more light has been reflected. And now based on that, you can say that this surface is black or this surface is white. We'll be using this a lot to follow when we're doing line following, okay? When we'll be doing line following. So in our next class, we'll be doing a lot of line following. So today, now let us, because we haven't added any sensor to our robot, let us just go back and learn how to program this robot to turn, okay? There are different turning techniques. So let us learn how to turn. So our robot is not moving because there is no code, okay? There is no code. So I'll come here and then I'll click on the motor. For example, I'll say motor 1, motor 2, motor 1, motor 2, move, move. Okay, if I say motor 1, motor 2, and then 1 second, okay, and then I reverse that action. What will happen? What will happen? And then I wait again 1 second. What will happen? Let's see. One, turning back. Very good. And then this one, there's no control. Have a look. Our robot is moving forward and then stopped, then moving reverse. If you were keen, you realize that it moved a shorter distance forward and then a much longer distance on reverse. Okay, I'll repeat. Forward, done, and then close to infinite. Okay, let's just see this robot. Let's take some time to study this robot. It's on the wall, but the clock is still counting. The wheels are still moving. So this robot is not going to stop unless maybe power iishe. So now, for us to ensure that maybe once this robot is here, it goes back again, we have to put this in a loop. This is open. We have no feedback. We don't know if that robot imefika huko ama haijafika. So we have to put a loop there, forever. So this robot will move forward, speed of 50, motor 1, motor 2, and that should happen in 1 second. And then the other second, it should be moving reverse. Then once it has moved reverse, for this second, it will go again forward. Okay, it will be a loop forward, reverse in the same distance. See, almost the same displacement, same distance. So we'll come back now. That said, forward, reverse. That said, allow me to introduce repeat. Okay, so before I introduce repeat block, I like to play again this code for us to understand. Now again, this code is here, it's not being executed. The only code that is being executed as we speak is the one with the header file, the one with RCU task 1. So this is the one being executed. This is not being executed. So I'll click and then you see, forward, reverse, forward, reverse, forward, reverse, forward, reverse. Okay, and this can continue forever. Okay, because it's forever again. It's in a forever loop. Okay, now I could just say that I want this to repeat 3 times only. 3 times. Now let's see the difference. 1, 2, 3. Okay, he did it 3 times, and then after the 3rd time, it exited the loop. And you can see this robot is still moving. I want you to be very, very careful because these are tiny concepts, but you'll need them. when you'll be handling complicated tasks. And that's the reason I took my time to show you a few maps and how some learners and educators have been able to program them. Let's revisit this. 1, 2, 3, and then it's exiting the loop. 1, 2, 3, exiting the loop. So it's by the time it's exiting the loop, it's exiting at reverse. So if you are keen, our robot is exiting the loop at this point. So it's doing this for 1 second, but then it's not going back to the first one. It's exiting at this point. So if we had this block, if we had this block for forward at this point, after it will execute it, because we are repeating this 3 times and then exit. So when it exits, it finds this block. Okay, it finds this block. So let me simulate that for you to see. 1, 2, 3, very good. Then reverse. 1, 2, 3. So when it exits that loop, it finds it exits the loop at the reverse, but then it finds a forward. Okay, so 1, 2, 3. It exits the loop and then finds a forward. Very nice. So we are done. We are done up to that point. So I'd like us to go to the next example. Let us tackle the next example. Let us tackle the next example. Let us tackle the next example. Now we have repeat forever. If then. Okay. If then condition. If then condition. If then. Okay. If then. So how can we test if then in this situation? If then, okay, this one needs either a sensor to check on a condition, and if that condition is true, then we do something. If it's not true, then we don't do it, or do something else. If then, you can have if then. You can have if then else, if then. So now, depending with whatever you want to achieve. So allow me to introduce one sensor that we had talked about earlier. I'll just introduce just one sensor. So I'll need to modify this robot. This being the front section, I'll need to just add one sensor. For the purpose of learning, I want to add infrared sensor. Let me make it upright. And then interesting. Let me have this is 3 grid axis. I need a part that will fit here. It doesn't have to look like this. I'm just trying to sketch something very fast so we can learn a concept. It doesn't have to look like mine. It can take any form. So I'll take this and I'll mount it there. I'll mount it there. I'll mount it somewhere there. Okay. Let me see this. Okay. So I just have one sensor here. Oh, sorry. I want to mount it. Yes, yes. Yeah, you are not center. Let me push it this way. Oh, sorry. Control Z. Okay, right. Now the center. So this is for learning. It's on P1. Okay, I could decide to assign it P2, P3, P4, P5, P6, P7, P8. So you can see I'm not able to assign it to an import. I'm only able to assign it to a P1 all the way to P7. So I'll give it a P1. Okay. Now, if we say that if sensor P1, okay, sensor P1 is seeing a black line. Do we have a black line here? No. So we need a map with a black line. So before we do that, we've done some modification of our robot, so we need to save it. So I'll give it a name. I'll give it which name? I'll give it 1 million stem. Let me just say CDC because this class is a recap for teachers from Compassion International. And yeah, of course, they're under 1 billion. CDC 005 build. Okay, so that is all right. I've achieved what I wanted. So next, I want to go back and pick, not save, and pick another map, okay, to help us understand to help understand that concept. So I'll pick this ellipse. Okay, I'll pick the ellipse. All right, and then now I'll import. Oh, I didn't save the code, but I can write it very fast. If then if I had an if block here and I had a sensor on P1, I was using Boolean get light sensor limiter P1. Now, if I see light, if get light digital sensor P1, then now if there is light, okay, sorry, if there is a black line, in that case, if there is a black line, okay, if there is a black line, so black line to mean this robot, if this sensor emits light and then close to no or light has been reflected back, so very little has been reflected back, then we want this robot to move forward, So we want it to move forward. So we'll go to motor and then say motor 1, motor 2, go forward. Motor 1, motor 2, go forward. Okay, that is all right. Now, what if this condition is not true? So let's first test this and see, because if you give a child an instruction that, hey, I want you to go to the market and get me, no, I want you to go to the shop and get me milk. What if they don't find milk? Do they come back to the house to you to inform you that, hey, I didn't find milk? Okay, if they found milk, they'll get you milk. But if they don't, now let's try this and see what will happen. Need to build the robot first. So I'll just come here very fast and import the robot because I've already built it. I've imported the robot, and then so I'll click on that. Did you see what happened? I want you to be very careful. Be very careful. Okay? Be very, very careful. Be very, very careful. I'm zooming this for you. Check the robot. The robot, it was just starting to move, but then it didn't move. Like it was just starting. It was just starting to. It was starting to. Okay, like ni kama imeshtuka. It's a vibration, but it did close to nothing. It didn't move. It didn't move an inch. It did not move an inch. Okay. Now, I want you to have a look at the data panel. I want you to have a look at the data panel now. Have a look at the data panel. Have a look at the data panel. P1, analog value is 733, digital value is 1. So P1, at this point, P1 is seeing the black line. That's why we have 1, and if you put P1 on the, if you put this robot on the side, you'll see 0. If you put it on this side, again, you'll see 0. But if you put it at the center here, you'll see this sensor will see this black line, and that's why we are getting a value of 1. Okay? Here, we are getting a very huge value because look at the analog values. It's huge because we are receiving back a lot of light. Okay? But here, it's very, very small because we are receiving a very, very small quantity of light. Now, on the digital value, we are getting 1 because this is a black line. Now, for this code to run, even if I put this robot here, even if I started this robot here, I started this way. Okay, sorry. Yeah. So so right now it's moving because when it was starting, it saw the black line. Okay, it saw the black line, and then this is just debug mode. So if I start it here, nothing will really happen. Okay. All right. So I'll come here and say that if you send a kid to the market, or if you give someone instruction, they need to remember it all the time, because now what will happen if this kid gets to the shop and then he or she forgets that whatever they were sent. So you sent the kid milk, but then when they go to the shop, they forgot that. So we need to have this at the back of our mind all the time. So this code, if we load it this way, it's going to run just once. But then we need to ensure that it's in a loop. Every time the robot knows that I'm running this forever. Okay. So I'll go back to control and then ensure that this part is running forever. Okay. So if I go back and I click, nothing is happening for the first few minutes, but then after some time, it picked. And you can see my robot is still moving, my robot is outside. So I'll click again this and then start the simulation. Nothing is happening this time around for some time, and then it started. So for here, there is some error margin because I believe this robot is starting at a noise. Have a look at here. It's reading 0. I mean, my robot is not seeing any sensor, any line. But then over time, because of noise and other factors, yes, maybe it saw the line, then it started moving. And once it starts moving, there is no any other code that is giving it the next instruction. So let's see. If we tell this robot, if you don't see a black line, so we go to operators. Okay. So now, now that we are here on operators, let me just take some time to introduce operators. Now, operators, just like mathematical operations, like greater than, less than, equal to, and, or addition. So these are just tools you can use to perform mathematical operations here. So if I want to negate whatever I have here, if I want to check if it's not receiving, so whatever is here, I multiply with a 0, and then I get a note. I get a 0 at this point. Okay. So if I don't C. If not, if not, if not, then negative 50. We agree that negative is, we use negative to reverse, but some cases negative could be forward. Now, depending with how you've connected your motors and how you've done your configuration. This configuration you can do on the physical robot when you have it, or you can do on the simulation platform by toggling here. You just click on the motor and then just toggle reverse if you don't want to deal with a lot of stress. But again, once you assemble your robot, test it in phases to proofread that it's in good shape, it's exactly what you really wanted. So I'll proceed to simulate this. Kindly be careful. You can see. You can see. You can see. Here, the robot is reading 0, and you can see it's really struggling to come back. It's coming back. Anytime it sees a 1 is stopping. Okay. You can see that. You can see that. You can see that. So I'll stop again, and then I'll start the simulation. You can see. Whenever we look at the data panel, whenever it is 1, it's moving forward. Whenever it is 0, it's coming reverse. Okay. Whenever it's 1, forward. Whenever it's 0, reverse. Thank you very much. Now, so so far we've learned about one sensor, that is light sensor, infrared. We've also learned about the operators, and we've used the node operator. We've learned about the basic motions, that is moving. I want us to conclude this class by learning about turning techniques. We'll keep learning more. We'll learn about the other sensors like ultrasonic sensor. We'll learn about the color sensor. We'll learn about the AI module, the computer vision plugins. We'll learn about utilizing the internal functionalities of the RCU, that is the E7 that we are programming right now. We learn about the 7-channel tracker, okay, that has 7 infrared sensors connected to one port. We learn about the different junctions. So next, because next we are going to engage more than one sensor, we are going to mount more than one sensor on a robot, and we are going to give these robot instructions. It's not going to be just forward and reverse. Okay, we're going to have turnings. So I'd like to request you, we go back and use and learn turning techniques. Okay, turning techniques. When you have a tight surface, how do you turn? When you have a smooth bend, how do you turn? Okay, what are the different turning techniques that we do have? So let me go back to the map. So I don't need to save this because I'm not going to use it that way now. And then I'll click on the coordinate ruler. This is just to help us in learning how to turn. Okay, so very simple exercise. We'll drive our robot till this point and then we turn. So I'll import our robot again. And then I'll do a code. I'll do a very simple code. Run motor 1, run motor 2, run motor 1, run motor 2, and then I have that. For how long? Here you can use time. Like for 5. Sorry, 5 is too much. For 3 seconds, and then you can say maybe stop. So I'll turn this to 0 and 0 again. So let me see what will happen. Very good, very good, very nice. Okay, so so that is okay, that is okay. What if I wanted this robot to start and face up? Start and face up immediately. So this robot is starting there. So if I wanted it to start and turn up, 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 up. So when you start, I want it to just start and turn up. So what do I do? Angle 90. So, and then this one, this motor 2, I just run it. I just motor 2. Let me see. If I'm here, and if my robot is here, and I want it to turn this way, I want it to turn and follow this line, then I'll be turning anti-clockwise. Okay, so anti-clockwise, there are different turning techniques I could deploy here. There are different turning techniques I could deploy here. Let me just detach this cord from the head so it doesn't turn. So for me to turn this direction, I could either reverse this motor and then drive this forward, or I could reduce the speed of this motor and then increase the speed of this one, or stop this and then have this go faster. So let's try the different techniques. So first we are starting with stopping motor 2 and driving motor. Oh, let me see. Let me see. So if our robot is here, so stopping motor 1 and driving motor 2 and driving motor 2 to 90. So motor 2 to be 90. So motor 2 to be 90. Speed 90. Let's see. Let's observe that. Very nice. Very nice. Very nice. Very nice. Very nice. Oh, yes, 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 yes. Then after that, I need to have like a stopper. Wait 0.5 seconds, and then stop. Okay. So let's see. Very nice. So let me just confirm if my robot is facing that side. Which one is motor 1? Which one is motor 2? If my robot is facing this side, which one is motor 1? This is motor 1. This is motor 2. Okay. So if I want it to turn, okay. So this is our robot. So if I want it to turn this direction, I could just, the different techniques. So have this motor. This is motor 2. Motor 2 go faster. Okay, and then this one goes slow. So the first one we tried same speed. Oh, okay. So motor one was to maintain at 0. Sorry, 0, 0, 0, 0, 0, 0. This one we were to stop. Motor 1 we stop motor 1. Very nice, very nice. So that is 90. The angle should be around 180. Those who did transformations. So very nice. What if I add to 70? Very good. Good. What if I say this 310, 310? What if we add the speed to 8? We adjust the speed to 8. What will happen? Very good. So it turned even faster. Though turning, some techniques require very low speed for you to be precise. It's like negotiating a corner when you're driving. So you can't do it at a very high speed. So that is good. So you can see I've managed to turn that way. What of by reversing? So if I was to reverse, then if I had this one maybe on negative 30, yeah, this one on negative 30, what would be the impact? Let's see. At the moment it's turning up to this point, so if you had it at negative 30, it's even better. You can see it's even better. It's even better. So for this case, you realize that if this is 0, have a look. If this is 0, you see that turn, okay? If it is 0, to mean the other wheel is creating some resistance because it's rubber. It's rubber, okay? It's rubber. You see? What of if I do this? I add negative 30. I give it negative. I allow these are the first wheel to move, but then to move opposite direction. A perfect turn. A perfect turn. So far we've learned turning. You can turn by reversing one motor. You can turn by reducing the speed of one motor. You can turn by, yeah. So let's try reducing the speed of one motor. So if we maintain this to be say 30, and then this one we maintained it to be say 50. Okay, what will be the impact? Let's see. You see, it's not that sharp. Okay, so let's see if we let's play around with the variables. If we have this as 80, very nice. What if we had this as 100? Very good. Now, there are different turning techniques. And we apply them in different scenarios. There is a situation where you have just a straight line this way. You just need to negotiate a 90-degree turn. There's a situation where you have a smooth curve. You need such technique, like reducing the speed of one motor and increasing the speed of another. And there are situations where you need to reverse one motor and then have one motor go forward. That is differential. So we'll get to explore the different techniques as we continue to work out different examples. Thank you so much. That was all for today. We've learned about of course, mini modification of a robot to suit your requirement for learning. We've learned about the motors, how to get started with the motor blocks. We've learned about how to get started with the sensors, and in this case we've worked with light sensor or infrared sensor, one piece. In our next class, we are going to have an array of them, at least 3. Now, these 3, we are going to combine what we've learned today, the turning techniques, okay? Like having these sensors, all of them scout for this black line, and then use the turning techniques to reposition this robot. Okay, so if the line is on the left, how do I communicate to the motors? How should they drive to compensate for me to have at least one sensor maybe on the middle to focus on the black line? Thank you so much, and I'm looking forward to have you in our next section. If you'd like to join 1 million STEM Teachers for Africa, reach out to us at afribot.africa or 07015 18100. Bye bye for now.